Hello, everyone. My name is Mohammed. I'm a senior security researcher and pen tester, and also I'm heading the offensive and research division at DTS Solution. So, anyone here attending from last year? Attended last year? That's good. See good hands. Anyone of you attended my session last year? That's very good. Okay, so for the people who don't know me, I'm on the offense side a little bit, so you will find my talks, my speeches are heavily focusing on how to do the bad stuff. It's just my nature. I understand that doing security, good security, you have to be on the dark side. You have to understand how far an attacker can go to implement the right security mechanisms in place. Other than that, I've seen a lot of attempts to implement architecture, which is have a lot of defense in depth. But again, this fails if you don't know the real threat. So in my talks, I always speak about how to defeat, how to bypass, how to achieve, but this shouldn't be used for any misuse, of course. Also, I want to highlight that my presentation uses some code which was obtained online. Okay, I need to give the copyright for the author, which I don't know. So the code is not 100% his, but I modified it. So I need to highlight this also. Okay, let's start. So basically, talking about viruses, malwares, worms, all this kind of stuff. So the first set that we ever faced was called Creeper. It's a computer virus which was just targeted at TNX OS operating systems. That was back on 1971. Also, Ray Tomlinson created what people believed the first antivirus to delete this Creeper. Actually, this wasn't the first antivirus. It was a virus to delete the virus. So it was a little misconception. Also, I want to highlight that executables can be infected without getting their size nor functionality altered. So if you have a 10K file, it can get infected and it has the same functionality and the size is the same. So it's very hard for you to notice. Also, I want to highlight that next generation antiviruses, they miss the obvious. Why? Because they have a high rate of false positives. They say that we are doing algorithms, we are doing math equations. They try to complicate things for user to think that this is the future, and they don't rely on signatures, which is the base, which makes them very susceptible to false positive, which the real threat slipping in. Okay, so the malwares these days are very sophisticated. They adapt on average of 10 evasion techniques at least. So anyone here doing reverse engineering malware analysis? That's very good. Okay. So as you know, it's getting harder every day with people detecting virtual environments, virtualization, sandboxing, debugging. So for us to understand this sophistication, we have to go one layer deeper to understand how it goes. And I don't know if you noticed, but the VP of Symantec highlighted once that antiviruses nowadays are dead. So we will just like see if antiviruses are really needed these days. Should we spend money on antiviruses? We should invest on antiviruses. How really they work? Do they worth the investment or not? Okay, so putting it very simple and clear, I really like Frederick Cohen's demonstration in 1987 when he said that one of the best solid theoretical results to study, that he demonstrated that no algorithm can perfectly detect all the threats in your environment. So you have to combine between static and dynamic. You have to inspect the file for your signature. You have to see its behavior. So you have to combine as much as you can from technologies to eliminate, or not, there is no elimination, but to reduce false positive as much as you can, at the same time get a very good rates of detection for your malwares which affecting your environment. So there is controversial, to be honest with you. There's a lot of people define how antiviruses really works, but this is my plain simple idea. This is how I comprehend it. You might be different from me. Some people say that sandbox and behavior-based are the same. Some people say that there is cloud-based protection. So it's different from everyone. But putting it very simple and clear, we have the signature-based. which is like having a database full of signatures and we matching. So we have a pattern matching, and it goes really simple. We can take, for example, an MD5 hash or hashing from the file itself and see if this matches. Sometimes we get bits from inside the binary itself, and most of the times it starts from the beginning of the binary itself. And most of the times it's a string, because you cannot take instructions. Instructions can change easily. That we have the heuristic based, which is also under the umbrella of static analysis. So what happens is that it detects the behavior of the code without really running the code. So it sees that how the code is instructed and sees that if it's posing any threat. This doesn't rely on signature, but this, if it's combined with signature-based detection, it will give you very good results. And that's for the static analysis. For the behavior-based analysis, sorry if I'm boring you, but this is needed too. So for behavior-based analysis, we observe the execution of the executable inside the memory. So actually, the antivirus sees what is being done when this executable is being executed. So does it, for example, modify registry entries? Does it drop file in system 32? What it really does. And based on this classification, there is a flags which can be triggered if this is doing beyond what should be doing. We have the sandbox-based detection, which is basically the same as the behavioral-based, but it happens in a sandbox environment. So you are not running the executable in your system to detect it, but you are running it on a separate system which detects the sample and sees if this sample is okay to pass to your system or not. For the sandboxes, you have two options. The first option is to let the first infection slip. And this serves the functionality more than the security. The other option is that be restrictive. Make sure that you see all the files before passing in to the end user. And in this case, you are causing a delay for fetching the users, so user fetching files. So this is one drawback. And there is mining based. So the mining based is basically the next generation antiviruses. So they detect patterns in large amounts of data. They do analysis, they do mathematical guessing to make sure that if the file might be infected or not. If you are only basing on the mining based detection, we will get a very high level of false positives. A lot of real threats will slip inside our network, which is something that we don't want. So, anyone here watches Mr. Robot? Good, a lot of geeks, amazing. So basically, this is the exact quote that Elliot told to his sister when she took the easy pass and slipped him a code which was already pulled online, which was coded by someone else. The code was already detected, which caused him to not succeed on his mission. So how we can bypass the signature-based detection? Actually, that's pretty simple if we are only bypassing signature-based. So that's simple. We need to find the signature. Where is the signature inside the executable itself? And there is a lot of tools. Actually, most of them are in Kali Linux already. So we have dsplit and evade. So we split the file into different pieces. And the goal is that each piece, it should be bigger than the previous piece, because the detection should be happening on the first, or as we assume. It differs from executable to executable. And whenever we go on, we split the pieces, we scan the pieces, and we find which piece has triggered the antivirus. We eliminate all those pieces, and we start breaking other pieces, till we get very near to where really the detection happens. When we reach this point, we have to modify the signature without altering the execution flow of the executable. This is very simple. We can escape if the detection itself, the detection string itself, is not really affecting the executable. So if we can get some NOP instructions, it will be really nice for us. We will escape it. You will not get detected, you will bypass it. Or we can modify it. So for example, if it's a string and it's like using the lower case, we can put higher case. And again, you bypass. It's very simple, very simple. You can modify it. You can compress. Actually, UPXing using compression utilities to compress executables, it will help you so much on evading some of the antiviruses. Some of them, of course, they will detect them as attackers, but this is not the subject. Also, we can encode. So if we can encode this, and we have, at some point, we could have a stub which can decrypt this, again, we can bypass. So signature-based bypassing is fairly simple, straight to the point. I don't find any complications there. So how we can bypass heuristic-based detection? Okay, so there is something called code cave inside every executable. And the code cave, why we have code caves? Actually, what's code cave first? The code cave is a null space inside every executable. This null space happens because of the compilers. Compilers have to do this. And this is out of our control. They do this because they need to realign the stack in the memory. We need to realign the sections inside the memory. So every compiler have its own way to leave gaps. Actually, it's being allocated via virtual allocx. And in this exact case, that you are fully capable of even creating new sections. So inside the executable, you can introduce new sections. So I can, for example, introduce a new section, bed it with hex, and start putting my own code. Okay, so there's a very good rule of thumb before doing this. We need to ensure that our malicious code is hidden via encryption, for example, with a simple stop. So basically, if you are encrypting your payload, and this is static analysis, okay, you are not executing the code, so it's encrypted on disk, so your AV solution, again, will fail to detect it, right? But there is a small trick. If you are lazy and you encrypted the entire text section, and for those who don't know, the text section, it's where it holds the entire code for the application. Some people are getting very lazy, and where they're doing this, they encrypt the entire text section. If you did this, you'll get detected again. So what happens? That's the normal case. You have an entry point of the executable. That's the flow. And that's here you get detected, okay? In the other case, we manipulate the execution flow. So we hijack the entry point. We get all the way down on the place that we made our code cave. We run the stub, and we go all the way up. This is all encrypted. As you can see, it's gray. And upon execution, because there is no dynamic detection at this phase, we are only talking about the static analysis, you'll be able to decrypt this in memory and execute it without getting detected at this exact phase. What happened? The execution, the executable itself, its size wasn't modified. We did something called dynamic batching. So we introduced dynamic code inside the executable without affecting the functionality nor the size of the executable itself. So this is how we bypassed it. So moving forward, how we can bypass the behavioral-based detection. So behavioral-based, as we highlighted earlier, it sees the characteristic of the executable once it's being executed, okay? And encryption will not help you here. Why? Because as Raul was highlighting yesterday at the same time as this presentation, he was saying that you cannot get a signature of an executable which is malicious from the encrypted code itself. It needs to be decrypted. And once the decryption happens, you can actually take the parts which you can make your signature of. So at this exact moment, to bypass this, you need to discourage the antivirus from running the stub. See, if the antivirus cannot run your stub, which is the decryption routine for your malicious payload, it will never be able to detect it, right? Because there is no behavior to see. So antiviruses, they do have limitations. So if you understand the limitations of antiviruses, because again, they are executables, they are applications, they are running inside your machine, whatever the operating system is, at some point, they do have limitations. You cannot do everything with antivirus. You cannot do everything with endpoint protection. So this very simple code, very, very simple code, it does a for loop increment of 1 billion times counter. This will discourage any antivirus. This has been tested and 100% working. So if you're doing this, okay, as you can see, this is the decryption stub, and this is the encrypted shell. So if you are doing this, it's a resources intensive for most of the EVs, but not on the PC. Actually, with the machines that we are using these days, you will barely notice that there is anything happening on the background. Also, antivirus typically ignore the stub. And if this happened, a bypass has been achieved. So this method is really nice and simple. It's clean, and it won't leave any system evidence for someone to investigate it later. So a rule of thumb, if the antivirus cannot decode your malicious stub which is already bypassing the static analysis, is defeating dynamic analysis. So if you have encrypted stuff, which cannot be decrypted, you are bypassing both dynamic and static analysis. Moving forward, bypassing sandbox detection. So most of the malware authors these days, they try to implement very, very smart ways to detect that if their systems, if their malware, sorry, if their malwares is being detected inside a virtual environment or inside a debugger, for example. So they implement a lot of smart techniques. But again, it's not very hard to understand that your code is running in a virtualized environment or running inside a debugger. It's not that hard. So again, sandboxes, they have hardware and processing time limitations. At some point, I cannot process X file for 10 minutes, and it's being already requested and fully downloaded, and user needs this file. Okay, so again, if we abuse these limitations, we can again achieve a bypass. So this simple example, it's a Python. Okay, I'm using a ready model. As you can see, most of the virtual machines, if for me, for example, or anyone is using virtual machine to do any work, I will not put 4 cores, for example. I will not put 6 cores. I will only do 1 core. So this is 2-liner code. I'll say that if there is a CPU count is more than 2, is less than 2, that exit, kill. Otherwise, do evil. So this is very simple. It's 2-liners that you can detect that if you are running in a virtual environment or not. So this is another unique trick that you can bypass dynamic analysis and especially sandboxing. So anyone familiar with NUMA, the non-uniform memory access in Windows? All right. Okay, it's used. This is used to increase the processor speed without increasing the load on the bus, the processor bus. So what's happening is that NUMA is linked to a whole set of functions declared in kernel 32. And people who used to work with kernel 32, it's huge, it's massive, it's very intensive. And if you are emulating anything related to this, it will get discouraged like this. And if this happened again, you cannot decrypt the stub. And if you cannot decrypt the stub, you again bypassed. So the question is that what I was trying to highlight that all the security mechanisms that we are use, they have limitations. They cannot, those are 2 examples. There is like 20 examples that can abuse different APIs inside the systems you are running. If you have like a big file, antivirus will mostly ignore. These kind of stuff, we need to have a good eye on them. So for bypassing mining-based detection, this is a very big subject. So I will only say only one word, fileless. If we're using fileless, defeating data mining techniques becoming very, very, very easy. Actually, I've been trying some of these stuff. Maybe if I come next year, I will just do a huge presentation about this, but not today. Okay, this is like creative bypass tools. I observe it in the wild. I'm not talking about Veal today. I know it's a disappointed. Veal is really nice, but today I'm talking about more tools which are maybe not very unknown. Anyone familiar with Hyperion? All right. So Hyperion is really cool. I really love the idea how it functions. So it encrypts the payload with 5 rounds of AES encryption. It uses a very weak key, which cannot be broken by our computer, but it leaves the hint inside itself. So this AES encryption key then discarded. So I encrypt our payload with an AES encryption, 5 rounds, I discard the key, okay? And after this, at some point you are defeating dynamic analysis because you'll never be able to get the key, and again, the stub will not be executed. If you are not executing the stub, you are not seeing the routine. If you are not seeing the routine, you will not get a pattern. If you are not getting a pattern, you skipped the detection. So once executed, the executable will brute force itself, which I find very, very, very unique idea. And will brute force itself and get its own AES keys and execute the payload, which is a win, a bypass. Actually, this is an output from Hyperion. You are fully free to try it. I'm not advertising it, so the logic behind the Hyperion is really nice, but this technique is not perfect because of 2 reasons I observed myself. The first reason is that there is a delay in payload execution because again, you are doing a brute forcing. So there is a little bit delay for someone who's familiar with the execution, seeing the file, observing the behavior, he might suspect something. Also, some antiviruses pick this routine as a backer because again, encryption. So regarding the limitation of this Hyperion, it's very effective and it's only detected by a few antiviruses. It's still running, it's still good. I tested it yesterday. It's very, very, very effective. Again, talking about another tool, Shelter. That's a polymetric executable via Shelter. So Shelter can generate unique polymorphic executable every time. It uses an executable file as a template, and it will do random amount of XOR, add, subtract, not operations to source of light executable in a way that with every amount of this instruction added, because if you are playing with the assembly, I can, for example, push one value and exchange it for 4 instructions to achieve the same. Okay, so it does that and it generates the payload decoder based on the chosen random operation. So I generate a random operation, and based on this, I generate the key which will decrypt my payload. So the decryption key is dynamic and based on the values of the specific CPU registers. So it's very unique and it's very hard to decrypt. And this will bypass again. So some basic sandboxing detection techniques, they were implemented to bypass sandboxing. So Shelter, in my personal opinion, is very promising. It picks up from where Hyperion stopped. It's fairly documented and effective. So the main subject of our speech, how to craft the unavoidable, how to craft something which will go straight all the way and give you what you are looking for. So you need to recon, you need to understand the target's antivirus features and vendor. You need to know what's running there. Talking about script kiddies for 1 minute. FUD, fully undetectable executables. Uploading files to VirusTotal. That's really nice. This is not how you do it. You are making it harder for everyone. Antiviruses are not ready to adapt with how fast it's going. And as myself, I'm very lazy. I need something which is already being done already, something which can bypass. But this will push a lot of security researchers to go beyond the unusual. And this will create a gap with the current antiviruses which are running. So we need to understand exactly what's the target's environment, what's the antivirus which is running, or the endpoint protection to be more general, and what's the features which they're employing. So again, it's way easier to write your own code. It's very, very, very easy to write a code which you can use, and it will never have a signature. It's very easy to write a code which doesn't use an obvious APIs calls inside the system, which are triggered by the dynamic analysis antivirus, because they have like small set of rules. Because if you are hooking the keyboard, for example, and using X API, this API will make it easier for them. Oh, the keyboard has been hooked. This is a keylogger activity. So try to generalize your code. I hate Elliot calling you a script kiddie. So try to be out there, write your own code. It's the best way. And if you are not writing your own code, you have to do some hard work and encrypt the payload with an expensive stub. When I say expensive stub, I'm saying that stub which is so expensive for the antivirus or the endpoint protection to decrypt. At this case, you are bypassing all the security in place. So this is a small example, okay? So this code creates a character array with XOR shell code and perform XOR operation, okay, with the key crypt, as you can see here. And using this key, I'm allocated in memory. I copy the character array and I define allocated memory and then execute it. Imagine that this code till now is very efficient, still very working, and still very FUD. Okay, be safe out there. Don't do anything malicious and have a good day. Any questions? Yes.
Yeah. Full disclosure, insert antivirus vendor here. Okay, so it sounds reasonable, but can you please clarify some sentences like antivirus is dead?
Okay.
Why is it dead? I mean, just because the Norton guy who wants to ditch
No.
antivirus and move to Verisign said
No.
so?
Of course, that's wrong. Antiviruses, in terms of the sophistication which is going on these days, as per the malwares which are bypassing every day, they consider dead, but they are not dead. They are 40% alive or less.
Are we talking about Clem AV here, or are we talking about full security suits?
For
Because
security.
yeah, well, Claim AV, come on,
No, Claim AV, we're not talking about Claim AV.
that's an
I
antivirus.
don't want to highlight any vendor, to be honest with you, but I will make it very general. Antiviruses, it's very good as first line of defense. If I'm telling you right now to ditch antivirus, you are 40 or 50% less secure. I'm opening the opportunity for a script kiddie to attack your network, or attack your systems. I'm not saying this. This is a very harsh statement.
Do you have any stats like figures, officials, research, something that proves that?
Of course, I can provide you with something, but it's not in this presentation. But I can do. I can.
I'm very interested because
Yeah.
we're doing very, very well.
I, I'm not denying this fact.
Okay.
Honestly, I'm not denying this fact. But you know, it's like observing this, trying this. I have like 3 antiviruses. I do a lot of analysis in my own time, looking at the most sophisticated evasive malwares. Don't tell me that there is no antivirus on the planet which can detect everything. Don't tell me that you can detect 0 days, for example, or detect like millions of dollars invested in money, malwares, cyber weapons. You cannot do that. Who discovered Stuxnet? Who discovered Flame? How long it took them to discover them? This is the question. I'm talking about 2 years of time frame. What happened in those 2 years?
What kind of security solutions they were running? That's the question. Were they running any security solution?
Yeah, it's
Because I don't see that in the reports, because nobody wants to mention vendor X has allowed APT Y to enter my network.
Again, it's not politics. I'm not raising any fingers. I'm just saying that based on my work, based on what I'm observing in the wild, based on what I'm doing on a daily basis, it's Iranian nuclear reactor. Don't tell me that they don't have protection.
Okay,
So-
secondly,
Yeah.
one last question. You had a slide on behavior-based protection,
Yes.
which is actually emulation. It's not behavior-based.
Which one?
Go back. There.
This one.
No,
That's the one.
this one. Yes.
Okay.
That's emulation. It's not behavior-based protection.
This is what?
It's emulation. Yeah, I'm not going to emulate a for loop that's not going to end. What behavior-based protection means that I'm going to write that process all the way from start to end.
Okay.
Right? Taking notes about what that process is doing on my computer, aka writing registry keys, writing on system files, and so on. And I'm going to assign it scores, right? Based on what it's doing. When it reaches a threshold, I'm going to suspend or terminate that process. This is behavior-based protection.
Yes, you're
This
right.
is very difficult to beat, actually.
Okay. I know it's very difficult to beat. Again, I'm not raising any hand. I'm not saying, see, that's a very big loop. Okay?
Sure, I'm not going to emulate that.
Yes, again,
But behavior-based protection
it's
is
expensive.
still working.
See, my entire talk is talking about expensive. I'm talking about expensive stuff, things that you cannot afford doing it. That's my main talk. I'm not saying that you should emulate this because it will be wrong, because it will affect the functionality. And as an end user, I will hate you to affect my functionality. If you did this, I will ditch your antivirus with all due respect, because I need the functionality and I need security. You need to find the good balance.
Understood. But you have beaten signatures, which is trivial, right? You have beaten emulation, but what about behavior? Because this is misrepresented. This is not behavior, this is emulation.
Okay, let's take it to scratch. So right now, behavior. Can you define behavior based?
I just did.
Okay.
Writing a process all the way from start to end, taking notes about what it's doing. When a
Okay.
threshold
Okay.
is
So
reached, I'm suspending the process.
that's good. For you to see this process, what if this process is encrypted? Will you be able to analyze it if it's encrypted? Can you do a pattern? Can you understand what's going on if it's
I
encrypted?
don't think I need to analyze writing a registry key. I mean, it's obvious that that
See,
process
I'm
is
not.
writing a registry key.
See. Right now, you jumped from the way from what I'm speaking to the decoded phase. This before you decode. I'm talking about before you decode. You don't know what's going on. It's decoded. It's decoded for you, and this for loop is so expensive for you to emulate.
Behavior is behavior. I mean, okay, you are running something on my computer with a malicious intent, right? I am detecting that malicious intent.
How you
And
detect it? Because you are monitoring threats, you are monitoring processes. If I'm doing this for loop, as you said, you are not going to inspect this. You are not going through this. And if you drop this, when the for loop ends, it will execute the malicious code, which you will not be able to see.
would you like to test that in production?
Actually, I tested that. You can give me your email address. I can send you
Of
results.
course. No, let's do it now. I mean, after the presentation, not tomorrow.
Actually, honestly, I didn't bring my laptop because I slept only 1 hour. But I can give you my business card. I can send you all the information you need. I can show you some evasive stuff.
Okay, that's it on my end. Thank
Okay.
you.